We have here a 24-bit comparator based on 9-bit comparator, and in this section of the code we have the inputs and outputs declared, and in this other section we have the architecture of the chip, and this chip works as follows. We input two numbers, and if the first number is bigger, smaller, or equal than the second number, we will obtain an output or another.
Hi, I'm going to present the SP2 assignment. So we have used the counter mode 16 millions, and we have implemented also the counter mode 16 millions by adding these two constants. So here we have the CC1 and the CC2 program. This defines the function of this chip. Next, we have the data path that is composed by a compiler 24-bit and the counter mode 60 millions. So here we have the inputs and the outputs as always. And then we have separated by three chips. First we have the comparator 24-bit, then the counter, and again the counter. As you can see, they are programmed different because one is implemented. Next we have the proctimer PHP file. So here we have the inputs and the outputs. Then we have that the proctimer is composed by the data path and the control unit that we have seen it in the another assignment, SP23. So data path has the outputs and the inputs that we have seen here. Next we have the control unit. Next we have the signals, and then the first chip is control unit, and then the data path. So next I'm going to show the Quartos. We have the RTL viewer. So this is what it looks like, the proctimer. Here we have the data path and here the control unit. We can also view the data path. So for example, this is the counter mode. Here we have the inputs and the outputs. Then we can see the counter mode, the implemented one and the other one, and the comparator to 24-bit. And here is the control unit. As we can see, our signals and all inputs and outputs are correct, so the proctimer, it works very well. This is the technology Mac viewer. We can zoom it and see it in detail. So this is what we have. This is the inputs. There are the inputs, and also here the data path and the control unit also, and the outputs here. So next I'm going to show that the circuit works correctly and the result is the expected, because we have here total resistors 53, and that means that we have 53 flip-flops, so this is correct.
Okay, now I'm going to explain the proctimer. As you can see, there is the VHD file with his inputs, outputs, signals, etc. And then the test bench. Okay, in the test bench we said that the clock period is 62.5 nanoseconds, and PC will be 256,000, but in binary, as you can see. And now I want to show the waveform. Okay, as I said, PC is 256,000, and I want to show you that it is correct, because we know that the timer out period is the product of PC and the period of the clock. Okay, so if we make this product, that is this one per 62.5 nanoseconds, it will be 16 million nanoseconds. And as you can see, is what it says, because we measure since here to here, and it works basically. Then I can show to the gate level that it shows that it works and it's correct. So that's all.